Hello there and welcome to this very simple little demo in which I'm going to talk through some of the use cases of Camunda's Agentic Orchestration and also then showcase how that actually looks in a real sort of running example. So let's get into it. The first thing I'll show, of course, is what are good criteria for Agentic Orchestration. So if you're already thinking about using Camunda's Agentic Orchestration stuff, how do you go about finding out you're using it for the right kinds of things? We have a very simple checklist here. The first would be messy, unordered input, things like PDF documents that you can't predict the outcome of, or free text emails, any kind of like sort of messy input that's kind of unpredictable and has no validation. Another good example might be for unique data structures between service calls. Very commonly, you might have multiple services all needing very specific data structure and needing an agent to be able to reorder that so that the calls between the services can be sort of made better and more predictable. And if lots of systems are involved, an AI agent is particularly good at sort of redefining variables in different formats. Multi-system integration for a single output. Really common use case here is when you have lots of different systems that are all needed in order to create a single output, especially in systems where, in examples where those systems actually have a hierarchy. So you might get the same data back from different systems, but you need an agent to determine which is most likely to be correct. For instance, if you have like a public data source and an internal private data source, but the agent is looking for everywhere to try and create a single output. Also, unpredictable procedures after task results, which is my fancy way of saying case management stuff. Kind of like if you have a situation where you are looking at an input and the potential of what to do next is quite varied and quite unpredictable, like looking through some sort of legal document and then working out whether how to deal with the red lines in it, for instance. You can never really predict exactly what you might need to do with that. Another one would be looping task activations. What I mean by that is, let's imagine a scenario where you have a data object. It needs to be changed fairly frequently for different reasons, and then after every change, you might actually need to do some sort of validation on that. Well, you can use an agent to be able to rerun tasks that maybe have already been executed, but now with a different context, the agent needs to run it again. Looping task activations are a pretty good example. And very importantly, I'll leave it last, is manual or repetitive tasks. Now, these come in two different flavors. Processes that take a lot of work, so long lead time, they take a long time and it's very manual, but maybe don't run that frequently. And the other end of the spectrum, processes that actually are relatively small on an individual amount of work, but they're very frequent. Now, generally speaking, a good use case contains maybe 2, 3, 4 or more of these particular examples. And once you have that sort of use case in mind, it's really easy then to go ahead and implement a solution to that, which is what we're going to talk about next. So on a practical level, how do you build an agent in Camunda? And that is as simple as building a BPMN model, specifically a BPMN model with this lovely lad here. This is an agent that is built within an ad hoc subprocess, which means from a process perspective, everything that happens within the scope of this subprocess is the decision making of what gets executed and how the results are dealt with is all owned by the agent. And how you configure that is you select an ad hoc subprocess and then you basically add on the configuration panel the various criteria that connect to the specific LLM. Now in this case you can see that we're using, I've specified the LLM I want to use, which is Anthropic Claude Sonnet 4. I've given some parameters and importantly I've given it its user prompt. Also here, which is invisible, is the system prompt, which is also really important. So we have the LLM we're going for, the system prompt, which details the goal of the agent and how it's supposed to, and what it's supposed to achieve, and then also a user prompt. So that's the scope of how to configure the agent. The next part is the really important part, because the difference between a bland old chatbot and a real functioning agent is the tools. And the agent tools are the tasks and processes and events and things that are happening in here. Every time you drop in a task, for instance, it becomes an available tool for the agent. The way you configure that is really simple. You add the tool, configure it like you normally would. If it's a business rules task, for instance, you would attach a rules engine. You tell the agent in natural language, you would type in, this is a tool that you use if you want to check some business rules, and then you define what the input looks like. The input might require the agent to create some data, or it might require you to take data from the current context. Either way, you configure the task in that way, and then in runtime, the way that works is we arrive with our user prompt to the agent. The agent then looks at its system prompt, looks at the user prompt, looks at all the tools that it has. Camunda sends all that information to the LLM, which then looks at all the options, responds back with the tools it wants to execute next, which is what this is showing. So it's basically saying the LLM's decided, here are the actions I want to take, and it gives those instructions to the engine. The engine is then responsible for executing those tasks. As each tool or each task finishes, it then asks the LLM, hey, you wanted me to run this tool for you. I did. Here's the response. What do you want to do next? And then you would actually loop back until the agent has decided that its goal has been completed. And that's how we build agents in Camunda. So here is our use case. It follows a lot of the criteria that I laid out initially. It starts off with a document, specifically a financial document from some company. Now, why that's kind of interesting is because, first of all, it's a PDF document, but it's also structured in whatever way the company who released it cares about. Now, what are we in this? This agent is an agent that works for a banking company, and its job is to look at this financial report and try and work out how that financial report might affect this bank. How does it do that? Well, these reports are really long and they have loads of numbers scattered around in there and loads of people's names and other companies' names. Depending on the report type, it might have different types of variables. But in the end, we want to find out everything we can about this document as it pertains to the internal knowledge of this bank. So let's talk through what that actually means. The agent here is configured as a Claude Sonnet 4 LLM, and its main goal is to try and create a final summary of based on the information in the report, combined with information that it can achieve using the tools it has to showcase the, let's say, what this tells us about this company's report. And there's a few options. The very first thing it does is it categorizes the document. And in this case, if we care about the document, the process will continue and the agent will try to get information about it. But if this task decides this document actually isn't a financial document that we really care about, we will actually say it's out of scope, and then we'll send it somewhere else to be verified by a human. That's how that works. Now let's look at the other tools that we have. Identification is a nice one. As I mentioned, this particular thing has customers mentioned in it, this document, other companies mentioned in it, and we can look up using these tools, which are internal data source actions, to find out if we know about this person being mentioned. Now, we also have a nice little task here, because let's imagine we look up this company, but it results in more than one company that comes back. Well, we'll have an agent that's basically going to look at the responses, look at the metadata, and sort of suggest what company this probably is, and then have a human decide. Now, why are we doing that? Because it's really important to know that we've actually got the right company here, and therefore we've added a human in the loop to make sure that we get that correct. Next, we have these rules. This is actually one of my favorite parts of this demo, actually. This is a DMN table, and this DMN table lets us, depending on the type of document and the location, to come up with respond with specific formula that can tell us a little bit about the health of the company. And this will help the agent understand what data and what variables it's looking for within that that document. And then finally, if we were missing some data, we'll go here and ask for it. Otherwise, we eventually create this report. So let's get into the weeds and actually start running this thing. The document I'm going to use in this case looks like this. It's a PDF document in which it has the name of a company. It's got a bunch of numbers somewhere scattered around the place. It's got people's names in here somewhere, but the key thing is it's quite unordered and it's all sort of in natural language. So the agent's got some work to do here. I'm going to start this by clicking up here and clicking run and start, and you can see that I have a little front end here where I can add my process. The process can actually be started from anywhere. I'm just going to start it from here. So let's open. And now we have our lovely document added. So now I'm going to click deploy and run. That's going to start our process and send the document there. And we can sort of check out what's happening in the agent by going into operate. So operate is our tool for sort of overview of the process from a technical perspective. So you can see that it started already, and the agent is now having a wee think about what to do next. It's now got all the tools it has access to, and it's decided to do a whole bunch of things in parallel, which is kind of nice. The first thing is it's running the categorization document. It's actually running this twice. That goes back to looping tools, right? It found two different customers, potentially two different people, and one of its goals is to make sure that it looks up all the people. So it's running this one twice. We also have here that it's looked up a company, but it's also found more than one result. So it's going to ask a human to pick one. And importantly, we have here that categorization has happened, and it's fine. Interesting thing that's a little bit kind of fun is that it started all of these in parallel. Now, the way BPMN works, if the document had been categorized as not of no interest, we actually would have just cancelled out of this and gone down here, and these would have all been stopped. But because we did it in parallel, we kind of were quite efficient in the fact that it did happen to be a good document, so we're actually going to continue using this instance. So let's take a look at what the agent has asked for here. So I'm going to open up task list. This is an end user front end where you can actually see sort of what the process participants would see. Specifically, this is saying, hey, based on your search Fusion Technologies, I found a bunch of companies. This is all the companies that they found, and they're suggesting that it's company ID 87, and that looks good to me. So I'm going to, as a human, I'm going to say, yeah, that makes sense. They're based in Las Vegas, apparently, and I'm going to put that in here. Looks like a good option. Cool. And let's complete the task. Cool. So now that's moved on, and the task is just going to disappear. And now we're going to go here and see what the agent's going to do next. Now, immediately the agent actually runs find required formulas because it now knows the company. So it knows where the company is based. It knows what what kind of file it's dealing with, and it can now find all the required formula it might need. And it's got those, and now I guess it should be able to create a report, I would think. Or maybe it's missing some data. I actually can't remember. We'll find out ourselves together. It'll be a fun experience for us. But in the end, the agent has decided it can create a final report. So if I go back to task list, I can see that the final report is here. And let's look through what it says. So it says that it's a quarterly statement. It's verified who the customer is. And if you look through, it gives the address and the contact details of the customer and the ID. It's also looked up the personnel mentioned. It mentions this person's Valerie Woods. We got a partial find, but it's pretty sure not the same person. And same with Catherine Spencer, where partial things. That's all right. The interesting stuff is down here where we have the actual formula that it was able to do this, and you can see here that it wasn't able to calculate the working capital. So I'm going to assign this to me, and I'm going to tell the agent, I don't know, maybe it should try and find the working capital. Can you please try to find the current assets? Because I really need this working capital variable. So I'm going to there's the document. I'm going to complete this task. Cool. So now I've sent that information back to the agent. So the agent has created the first draft of a report, but I didn't quite like it. It needed more information. So now you can see that it's triggered this task down here where it's trying to find public information on the company. Now the reality is this is mocked, so it's going to trigger some random test data. Now, as a final little word, I'm going to just talk a little bit about why the way Camunda builds agents is particularly good if you envision a more complex growth of your agent technology. And that's because Camunda basically is there for every single step of the growth of agent complexity in terms of both technical and maintainable ability. First of all, adding more tools. It's incredibly easy. You saw there's actually a separation quite clearly between the LLM itself and how that's configured and the tools it has access to. That means that you can quite easily add more tools and therefore more capabilities and therefore solve more complex problems. Now, Camunda's not alone there, but if we move to the next point, we have a really easy way to integrate a diversity of endpoints, both as far as like involving humans directly as they're called from the agent, but also different technologies that require different protocols to get those services connected. And that's also, I think, possible with existing services. But if we look at the from this point on, things get very, very particularly good for complexity growth with Camunda, and that is about time to execute. The longer a process runs, the more complexity the engine that basically controls that agent needs to be, because it needs to handle things like state over the course of a week. What if it takes the agent a month or something to solve that problem? Well, not only does that need error handling that might occur there, it might actually need to store the state in a way that absolutely won't be forgotten, but also it might need to migrate to a new process because you've changed it in the meantime. Maybe you've added a new tool, new version, and all of that's part of Camunda. And as that complexity grows, you still need transparency. As you probably saw from what I was building, everything the agent is doing, you can see. You can see which tools it's activated. What I didn't show is, but you can see the reasons why the agent actually chose those, because we get the chain of thought back. And you get a huge amount of governance, the ability to actually have a high-level agent call sub-processes that are also agents. So you can end up having a really complicated and complex structure of agent growth. Hope that helps you understand how Camunda kind of works with agents and activities. Let me know if anything strikes your fancy. Come find Camunda and we can help you build some stuff together. Cheerio.